Let us derive time-independent Schrodinger wave equation for one-dimensional space. Consider a particle of mass m moving with the velocity v, accompanied by the matter wave of wavelength given by lambda is equal to h divided by p. Let us call this as equation number 1, and this equation was given by de Broglie's hypothesis in the discussion of real nature of matter. The physical situation of a particle is described by the wave function psi and is given by psi is equal to a into e to the power I kx minus omega into t. Let us call this as equation number 2. Now, let me rewrite the expression by splitting the space and the time variables. Capital Psi is equal to a into e to the power I kx into e to the power minus I omega t. Let us call this as equation number 3. In this equation, we can replace a into e to the power I kx by small psi, which can be considered as a function with the only the space variable. Now, let us differentiate this equation with respect to space and time twice. Let me consider the differentiation of psi with respect to x so that I can write the expression as d psi by dx is equal to d small psi divided by dx into e to the power minus I omega t. So in this equation, we are just differentiating the function with the x variable, that is only the small psi. We will keep constant as e to the power minus I omega t. Let me differentiate the same equation one more time so that d square psi divided by dx square is equal to d square small psi divided by dx square into e to the power minus I omega t. Now let us differentiate the same equation with respect to time variable so that we have equation d psi divided by dt is equal to small psi into minus I into omega e to the power minus I omega t. This equation was differentiated using the formula d by dt of e to the power ax. So we know the result for this as a into e to the power ax. So that we have this expression, and differentiating the same equation one more time with respect to t, then we get the equation as d square psi divided by dt square is equal to small psi into minus I omega whole square into e to the power minus I omega t. Here in this equation, small psi has a variable only the x, so that we cannot differentiate small psi, hence we keep this as constant. So by simplifying the expression, we got this as d square psi divided by dt square is equal to minus omega square into e to the power minus I omega t into psi. Now, according to traveling wave equation, we have the equation d square y divided by dx square is equal to 1 over v square into d square psi divided d square y divided by dt square. By analogy, we can replace y by the wave function psi. Hence, I can write the expression as d square psi divided by dx square is equal to 1 over v square into d square psi divided by dt square. Now let us call this as equation number 4. So substituting d square psi by dx square and d square psi by dt square in equation number 4. Hence we got the expression as d square psi divided by dx square into e to the power minus I omega t equal to 1 over v square into psi into minus omega square into e to the power minus I omega t. Let me cancel out e to the power minus I omega t on both the sides. Now the equation becomes time independent equation. So we are just cancelling out the time part of the equation. Hence we will only remain with the variable x. Hence the equation is called as time independent Schrodinger wave equation. So now we have taken off the time variable on both the sides. Hence our equation becomes d square psi divided by dx square is equal to minus omega square divided by v square into psi. From our earlier discussions, we know that omega is equal to 2 pi f and v is equal to lambda into mu. By substituting for omega and v in the above expression, we can write the expression as d square psi divided by dx square is equal to minus 4 pi square divided by lambda square into psi. So in the numerator and denominator, we are cancel out frequency terms on both the sides. Hence, we write the expression as d square psi divided by dx square is equal to minus 4 pi square divided by lambda square into psi. Now I am rewriting the expression for 1 divided by lambda square. 1 divided by lambda square can be written as equal to minus 1 divided by 4 pi square into psi into d square psi divided by dx square. Now let us call this as equation number 5. So once the particle is moving, it possesses some kinetic energy and hence at the same time it has some potential energy. So the total energy of the particle can be given by the equation total energy is equal to the sum of kinetic energy and potential energy. E is equal to kinetic energy plus potential energy. We know that the potential energy of the particle is considered as the capital V and the kinetic energy of the particle can be given for a microparticle as equal to p square divided by 2m according to de Broglie's hypothesis. So here we can have the expression for total energy as E is equal to p square divided by 2m plus V. By the de Broglie's wavelength for a matter wave, we can replace this p square as h square divided by lambda square. Hence, I can write the expression by substituting for p square as h square divided by lambda square as E is equal to h square divided by lambda square into 2m plus v. Now let us call this as equation number 6. So substituting equation number 5 in equation number 6. Here in this equation 6, I am substituting for 1 by lambda square. Now I got the expression as E is equal to minus h square divided by 4 pi square psi into 2m into h square into d square psi divided by dx square plus v. Now I am writing the expression as E minus V is equal to minus h square divided by 8 pi square m into psi into d square psi divided by dx square. Now rearranging the terms and I am rewriting the expression as d square psi divided by dx square plus 8 pi square m psi divided by h square into E minus V is equal to 0. This is the final expression for time independent Schrodinger wave equation for one dimensional space. Thank you.